All right, so double replacement reactions. These are all ionic. So let's look at the first one, silver nitrate and zinc chloride. So in a double replacement, the cations switch places with each other to have new anions. So if they react, it's going to be zinc nitrate plus silver chloride. Okay, and the fact that this is IDE, that tells me that that's the element, but the fact that this is ATE tells me that this is a polyatomic ion. It's going to become important in a minute here. So, in order to prepare for balancing a chemical equation, I'm going to put a blank. The silver has a charge of +2. I'm sorry, +1. And nitrate, NO3, has a charge of -1. So, okay, it is currently neutral, so I don't need to adjust the chemical formula. Okay, plus zinc. Zinc has a charge of +2. Chlorine has a charge of -1. So in order to make that neutral, I need to have 2 chlorines. So now I have a +2, -2. Okay, zinc chloride is neutral now. Okay. React to form. Okay. Zn has a charge of +2. NO3 has a charge of -1. Okay, so I'm going to need 2 nitrates. So I'm going to put parentheses around this. And I'm going to get 2 of them. So now zinc is +2, nitrate is -1. It is neutral. So zinc nitrate plus silver Ag is +1. Chlorine is -1. So it's neutral. All right. So let's take a look. Silver nitrate. So I have 1 silver on the left. I have 1 silver on the right. I have 1 nitrate on the left. Ooh, I have 2 nitrates on the right, so I'll double this. So the nitrates are fixed, but now I have 2 silver on the left. I need 2 silver on the right. So 2 silver on the left, 2 silver on the right, 2 nitrates on the left, 2 nitrates on the right. 1 zinc, 1 zinc, 2 chlorines, 2 chlorines. All right, this is balanced. But if we take a look, we need to find one of these materials that precipitates out to know that the equation proceeds. So zinc with nitrate, that disassociates. So this disassociates. And that means, and just for giggles, let's take a look. Silver plus chloride is a precipitate. that means that we are balanced and there will be a reaction. Okay, double replacement, we have ionic reactions. We have copper 2 hydroxide and hydrogen acetate. So because they're double replacements, the copper is going to replace the hydrogen and the hydrogen is going to replace the copper. All right, so we get copper acetate and we get hydrogen hydroxide. All right. So when I go to write the balanced chemical equation, I translate. So this is copper, but it has a +2 because of the Roman numerals here tell me that it's +2. And hydroxide is a polyatomic ion, and it is -1. So in order to make it neutral, I need 2 of these. So I'm going to put parentheses because it's a polyatomic. So, and then 2. So now there's +2, -2. And we are neutral. Okay. Plus hydrogen +1. Acetate is quite the polyatomic ion. Acetate is C2H3O2. And that whole ion altogether has a -1 charge. So +1, -1, hydrogen acetate is neutral. Okay, if that reacts, it will react to form copper hydroxide. Oh, I'm sorry, copper acetate. So copper with a +2 charge and C2H3O2 with a -1 charge. Okay, so I'm going to put a parenthesis around the whole polyatomic, and I need 2 of them. So now +2, -2. All right, now copper acetate is neutral. All right, plus hydrogen with a +1 charge and hydroxide with a -1 charge, and it is neutral. Okay, kind of just a wise idea. I'm going to put the hydroxide in parentheses here. I think you'll see why in a minute. So HOH, and yes, I know you're screaming at your screen at the moment, but so everything's neutral. So now there's 1 copper on the left, 1 copper on the right to balance. There's 2 hydroxides on the left. There's only 1 hydroxide on the right. So I'm going to make 2. Okay. And C2O3, H3O2. There's 2 on the left. Oh, I need 2 on the right. And then hydrogens. Oh, there's 2. So now it is balanced. All right. I know. If you are slick, you will notice that this is also known as water. You could write it H2O, but I think that honestly that obscures the fact that there's a hydroxide in there. All right, that means that this is balanced. And now let's check to see if there are any precipitates on this side. So copper reacts with acetate. So copper 2 reacts with acetate and is soluble. H2 water dissolves in water. So actually this reaction, there is no reaction here. Huh, I would have thought that.